So here's just a couple more. The one on the left is going to be that heartbeat theorem. I know because the altitude in the middle is labeled, the pieces at the bottom are labeled, so I'll use that theorem to solve that one. And the one on the right, geometric mean leg theorem, or the boomerang, because I have the leg marked. I do not have this altitude marked in the middle, and I have the two pieces of the large hypotenuse there. So these are a little bit harder. They involve some quadratics in the solving here, so I wanted to do these separately just because I didn't want the other video to be super long. So right here on the left, we're going to do that heartbeat theorem here to set it up. So it'll be 2w over 3w equals 3w over 4w plus 3. Now you may or may not notice right off the bat that on the left side, you could divide, simplify, and reduce out the w's. It's going to make your solving quite a bit easier because of that, that takes out the quadratic factor of it. When you do this, in Algebra 2, you would actually want the two answers, and when you divide out a w like this, it's actually taking out a solution of 0. 0 will not work in this problem situation, so it will not affect us to simplify it out like that. So now we're going to cross multiply and solve. So 2 times 4w plus 3, and then 3 times 3w. And so distributing over here with the 2 will give me 8w plus 6, and on the right side, 3 times 3, that'll be 9w. So we can just subtract the 8w, and you see that 6 is w. So it turns out being really easy if you divide that w out. On the right side, we are going to need to first figure out what the entire length of the bottom is. The 2y is just this part over here. The y minus 1 is this part over here. So the entire piece is needed for this theorem to work out. So we're going to have to combine them together, which would give me 3y minus 1 for the whole hypotenuse there. So we need the y minus w over y plus w over 3y minus 1, doing that boomerang setup. So y minus 1 over y plus 1 over 3y minus 1. Now, we have binomials in each spot, which means that when we cross multiply, we will end up foiling or multiplying these however you know how. I'm going to use the FOIL method. So setting up that times that, that times that. Now we need to multiply them together and solve. So first times first, 3y squared, inside, negative 3y, outside, minus 1y, last times last, plus 1. That's the left side. I'm going to simplify it. Now for the right side. First times first. Outside times outside. Inside times inside. Last times last. 1 times 1. And simplify that down. And then you end up with a quadratic on each side, and to solve the quadratics you need to get everything to the same side, make sure that 0 is on one side by itself, and then you can factor to solve. I want my y squared part to be positive, so what I need to do is I need to subtract everything from the right side and move it over to the left side. So I'm going to subtract the y squared from the y squared. I'm going to subtract the 2y from the negative 4y, and I'm going to subtract the 1 from the 1 there. What this will leave is it will leave a 0 on the right side. 3y squared minus y squared is 2y squared. Negative 4y minus 2y is negative 6y. 1 minus 1 is 0 for the constant. So I'm at, this equation to solve. Since it's not a trinomial, I don't need to factor it like I would traditionally factor it. I need to factor out the greatest common factor. The 2 and the 6, the greatest common factor is the 2. Between y squared and y, the greatest common factor is y. So I'm going to factor a 2y out. If I take 2y out of 2y squared, I'm left with just y. And if I divide 2y out of negative 6y, I'm left with a minus 3. You can check that if you distributed, you'd get back to that, and then you know you factored it correctly. And then each piece here will give you an answer. You set each one equal to the 0, and then you solve. So 2y equals to 0 gives you a y value of 0. Y minus 3 equals 0 gives you a y value of 3. Then you go back and you check, could you have a 0 or a 3? If I plugged in 0, I'd get a 0 here and I would get a negative number there. That would not make any sense. So I don't want to keep the 0. It's not a good solution. And the only solution that would actually work in this case is the 3.